All right, we're live. I don't know how much of a delay there is. Just a friendly reminder to everybody that if there's a lot of crazy things going on in the world right now, it's very easy to talk about politics and argue about things like that, but the chat is moderated, so everybody be nice. And we're talking about much bigger things, such as the universe. And I'm here with Mark, and he is, I'm very, very thankful to have him here to answer our questions. We have a lot of really great questions. And of course, this whole thing is to help promote the Flashbulb Adler VIP Bundle, which is happening over at Groupies, where you can pay what you want for 40 albums, well, 40, I don't even know how many albums I have, 44 albums and over 30 hours of music. How you doing, Mark?
I'm doing great. Yeah, very excited to answer these questions, and very excited about your bundle. So, thanks so much for supporting the planetarium. It's been a really tough time for museums trying to survive. Our doors are currently shut, so this stuff really helps. Thanks so much.
Yeah, and I'd like to sort of add in for those watching that, like, the Adler is not just a museum. They do a lot of research and things like that, and unfortunately, a lot of your income comes from the public entering your museum. And you guys have done right by the pandemic. You've just been like, no, we got to take the financial hit and do the right thing, and not contribute to the spread of the pandemic. So that's so I'm more than happy to do whatever I can to help that. See if I have any comments that are saying. Somebody says which pixel is whole 5 pixels from my cam. Well, I'm not that pretty, so I guess that works fine. All right, let's look at some questions here. The first and pretty important one. What is the best way to deal with the growing problem of science denial and, more recently, science hatred? Most prominent current example, anti-vaxxers, anti-maskers, climate change deniers. What do you think, Mark?
Yeah, well, this is a really good question. And, I guess I'm sort of 20 some years into working in the field of science communication. And initially, some of this stuff seemed like not that important. If somebody didn't believe we landed on the moon, I just thought, oh, it's a weird fringe thing. I'm not too concerned about it. But what's happened in the last 5 years is the explosion of these theories, and in particular, and the questioner gets this right, in areas that really matter and can really impact our lives, right? So if we don't believe in climate change and we don't do anything about it, that is an existential threat to our future as a species. And, if we don't believe in masks or vaccines, that affects, what happens right now. We just found out, right, 130,000 extra people would be saved if everybody wore a mask. There's a growing body of research in how to talk to people who are in this position, and the first thing is to have empathy for where they're coming from. So it's one thing to put people down, call them stupid, make fun of them, and that just causes them to retreat and not listen to the rest of your argument. So I think the most important thing, and I've had many times where I've been on a flight and with a talkative person, and I find out they don't believe in climate change, and we spend 2 hours talking about climate change. But the first thing you really need to do is listen to them, hear where they're coming from, see if there are areas where you have some sort of common ground, and then use that to start to build up your credibility, and then you can slowly in the position. But people don't change their minds about issues like this easily at all. It's very, very hard.
I find it interesting how a lot of times you'll find it buried in someone. You'll find somebody who's very scientifically minded, and then all of a sudden they're like, yeah, but I won't eat anything that's a GMO. Where you're like, well, that, you always find these one little thing. But yeah, I was reading something recently that I don't remember where the article was, but it talked about approaching, sort of what you said, just calling them stupid doesn't help. That probably turns them from the science denier to the science hater. But they didn't come to their conclusions using necessarily rational and logical thoughts the way that science works. Science comes to their conclusions with rational and logical thoughts, but these are conclusions that were emotionally derived, and so it's interesting because I have the same question myself. Like, how do you appeal to them on that? How do you sort of wrangle them into knowing what the truth is, and I guess knowing how truth works, because we're in the post-truth era now, as they say.
For me, there's a documentary called Behind the Curve about the flat eartherism, and I found it really powerful because you really got insight into why people believe what they do, and so much of it comes down to identity. People have found a community of people who believe the same way they do, and it's so embedded in their identity that being presented with having to reject it, that idea is also really rejecting who they are, and that's why they can be very defensive. So you have to be very careful.
Yeah. Well, yeah, that's a good question. A great one to start with. Topical, unfortunately. All right. What is the probability that we will fill low Earth orbit with satellite and other space trash, thus preventing our ability to launch space trash removal technologies and seal ourselves in a trash tomb?
Yeah, I thought the last question was depressing, but
yeah.
So, we've been sending more and more stuff up there, and a lot of it just dies, right? And there are plans, now to put up these huge constellations of satellites, tens of thousands of satellites. I think I just saw something that already from the Starlink constellations that have gone up, 3% of those have died already. And one thing that happens is when you have stuff up there, it will smash in. Occasionally there are collisions. And in a collision, two things can make tens of thousands of things. And I think the real fear is that, and there's this idea of this, sometimes called the Kessler syndrome, that there's this limit where you get crowded enough, you set off this cascading chain of interactions where one collision will make many more things. Some of those things will hit other things. And it's just a run effect where we now fill low Earth orbit. Remember, things are traveling depending how high up you're, but tens of thousands of miles per hour. And that's just a runaway effect, and we fill low Earth orbit with debris. So that's why we need to be careful, and we need to clean up our trash.
Yeah. Isn't there, did I read something about there sort of being I guess right now we're not doing the best job at like international agreements, but isn't there some sort of plan to restrict the amount that we're sending up or something like that? Or did I just have a dream that was way better than reality?
Yeah. I'm not exactly certain. This is if we have good agreements, and I don't think I'm not sure. There's the Outer Space Treaty, which governs how we deal with space. Things like going to the moon, and you can't claim territory and things like that.
Yeah.
And that actually it applies to private companies as well, because that's the big thing here, right? Because it's any of the actors. We have to have more. It's gotten quite easy to send up a small satellite. In fact, we're developing some at the Adler Planetarium right now. But I'm not sure about solid agreements to limit the number of stuff that goes up there. I don't. Yeah.
Okay. Well, moving on. Maybe this one will. Oh, this one's not as depressing. Mars. What would happen in our lifetime? That's Ben Weinman from Dillinger Escape Plan, by the way. A celebrity question.
What do you think, Ben?
I'm a little jaded. I signed up and did the application for Mars One. I was willing to go there and never come back. I signed up for that, but I got rejected.
You did? My wife signed up for that as well.
Okay, yeah, and at the end of it, I feel like I kind of got scammed or something. I feel like it was just sort of a money generating thing. But yeah, it was kind of funny to be like, after I signed up, I realized like, oh, I have nothing to contribute, like professionally. Like, what am I gonna like play music for them or just like have let them know my harebrained ideas on how we should continue surviving? Yeah, I think it'll happen within our lifetime though.
Although, if you've seen like the way Ben's able to hack together technology, I mean, you could totally be like Matt Damon in The Martian, and
Yeah, I could be the MacGyver of the Mars One mission.
that's right. Yeah.
Yeah. I mean, I suppose if I had to bet, I would guess that it would happen in our lifetime. Why not? It's plausible, right?
Yeah. No, I totally think it will happen. It's I mean, technologically, we've sent rovers there. We can send people, and you're right. One time, I was lucky enough at the Adler Planetarium. We had lunch with who did we have lunch with? Well, anyway, the discussion of like going to Mars came up, and the difference between just going there and staying and going and come back is a factor of like 8 in energy, right? It's huge.
Yeah.
And that's why it's so much easier just to go there. But the technical challenges aren't just bringing people back. It's staying alive once you're there. It's making food. It's all those potatoes, right?
Yeah.
It's bringing enough stuff to stay, and it's keeping you alive on the trip. And that length of a trip, which is probably 6 months at least, dealing with the radiation exposure is really critical.
Yeah. I know that the way back is much more difficult, which is why I signed up for the suicide version of the I'll never come back one. All right. Some of these questions, by the way, cut off, or some of them I've shortened just a little bit. Are black holes and parallel universes related in any way? We've discovered so much about both that it begs the question on the discoveries made.
Well, when we talk about parallel universes, we can mean lots of different things, right? So in general, this like idea of the multiverse. I'm hearing a little bit of an echo, Ben. I hope that's not me.
I am. It could be coming from my headphones, honestly. I'm wearing open-ended headphones, so.
Yeah, because it sounds to me like it's the YouTube being delayed.
Is it better now?
It is better now.
Okay. Yeah. Well,
Thanks.
So open-ended headphones, they don't seal in sound. They just make your ears feel breezy and nice all day. So go ahead.
So let's talk about this idea of a multiverse. And that's the idea that there's more than one universe, and there are different kinds of multiverses. One you could imagine, it just comes from the fact that imagine we have an infinite universe, and stuff goes on forever. There are going to be parts of that universe that are so far away from us, we'll never get any signal from them. As far as we're concerned, we're completely separate. Not only that, if it's truly infinite, you begin to have every possible combination of atoms that could arrange themselves in any state will happen again and again throughout the universe. So there's probably some other part of an infinite universe where we're having the same conversation, or maybe a slightly different one, or maybe
right.
Maybe I'm the musician, right, and you're the scientist, and we're doing the same thing. But there are other ideas about the multiverse. One comes from this sort of alternate interpretation of quantum mechanics called the many worlds hypothesis, where in quantum mechanics things are probabilities, like is the cat alive or dead in that box, and in the traditional picture, well, once we make an observation, we know which state we're in. But in the many worlds hypothesis, the cat is both alive and dead, and when we make that observation, we're just choosing which path. But all those paths actually exist, and they're out there. And these are just a couple of different kinds of ways you can get multiple universes. But the relation with black holes is that black holes deal with create curvature of space. And that could potentially allow connections between different universes. So, and that's this idea of like Einstein-Rosen bridge, the wormhole, basically.
Okay. Which multiverse theory, or I guess which version of that are you a big fan of? Which one's the
I
leader
didn't
for
give
you?
you, I didn't give you all of them.
Yeah,
But
there's
I
a
think
bunch.
like
Yeah.
the one that's pretty standard cosmology right now has to do with for a long time we've believed in this something called inflation, and not like money inflation, but the inflation of the universe, and that explains a lot of properties in standard cosmology. And what that means is that very early on, there's a phase transition in the universe that causes runaway expansion of the universe. And the idea is that this is really the bang part of the Big Bang. It happens in a fraction of a second, but it takes things that were on the quantum scale and magnifies them up to be the size of our entire universe.
Hmm. So that kind of goes in with I don't know if there's another question in here, or if this is just a question that maybe was just banging around in my head. Um, or maybe I've read this somewhere. The universe is allegedly expanding faster than the speed of light. Is that right, or is that believed?
Yes.
Okay.
Yeah.
And so we're pretty much never going to. Yeah, it's pretty much unobtainable due to us being restricted to the speed of light, unless we deal with entanglement or something.
Yeah.
All
Yeah.
right.
Actually, yeah. So, well, actually, let me step back. So, this inflation, we think it happened, and then you might ask yourself the question, well, if it happened, why did it just happen once? And there's really no good reason for that. And if it did happen once, it's likely to have happened many, many times. And each one of these inflationary events could be creating a new universe. And this is this idea that's now known as chaotic inflation, but it naturally leads to a multiverse. So that's become pretty standard cosmology. Even more standard cosmology than that goes back to 1929, Edwin Hubble and the discovery of the expansion of the universe. And the idea of that is that, it's like let's imagine a 1D universe that's a rubber band, and we stretch that rubber band. Everything gets farther and farther apart.
Okay.
Now imagine you have a rubber band long enough, say I'm stretching it so I'm pulling my hands apart at 1 foot per second. If I go 2 feet out on that rubber band, it's going at 2 feet per second. If I go at 4 feet, it's 4 feet per second. So you always, the farther away you go, the faster any 2 points are expanding in this sort of your stretch. And eventually, if you go far enough, you're going to hit the speed of light. And that's not forbidden by relativity. Points in space can move away from each other faster than the speed of light. What is forbidden is to send a signal between them. So that place where the universe is expanding away from us at the speed of light, that becomes our horizon.
Okay.
And that's the limit of what we can see. In a big enough universe, you have multiple disconnected horizons, which is essentially saying that they act as separate universes.
That's pretty insane. It's a lot to think about. It's funny because I feel like any one of these questions I could talk about for like I would just continue being like, okay, tell me more. But but obviously we have all these. This one's fun. How loud is a black hole? Can I get this one?
Yeah,
maybe? Or can I take a shot at it?
Yeah, no, the audio ones, you take it.
Yeah. So I would think that a black hole would be the most silent thing possible since it doesn't let anything escape. But I don't know how, nobody's ever tested this obviously, but if I had a 1,100 decibel speaker, it would create a black hole since the energy from the speaker would act as mass. But that's a bit of a number trick because decibels are logarithmic, which is just a horrible way of measuring anything for a practical person to practically use, isn't it? Like if you were driving like 83 miles per hour and the speed limit was 80, you'd be going double, right? Or something, like if it was logarithmic. So it's like terrible. It's more of a number trick. But yeah, black hole, to answer the question, a black hole would be utterly the most silent thing in the universe, probably, I would imagine. Am I wrong?
Maybe, but it depends what that black hole is doing. And in particular, so when we can get two black holes together, and that's been one of the big discoveries the last few years, is we've been able to detect black holes merging with each other. And well, sound is vibrations, right? So vibrations in the density of air, but this creates density or waves in the fabric of space itself. So it's kind of like a sound. So gravitational waves, we often refer to them as sort of listening to them rather than seeing them. And so, if you consider that a sound, gravitational radiation, they are emitting, especially when they start to do something. So when they just sit there, or if they spin nicely, they don't necessarily give off this radiation. But if they start vibrating, or especially really the practical time is when to each other, they'll give off this radiation.
Yeah, and when they merge, it kind of turns into a binary black hole. Don't they just sort of stay in like a figure eight formation, or is it always random? Or
they'll come down to a single black hole.
Okay, so it eventually sort of ends up. All right. Yeah. I think there's actually a question. I thought I peeped a question about that later on. All right. I've heard it said that the Earth is actually traveling in a straight line, and the sun is distorting its reality. Can you explain space-time in layperson's terms? Yeah, go for it.
Yeah, well, I wouldn't put it that way. So I think this is. I think that question comes out of an attempt to explain the way general relativity works. And so, there are basically two major theories of gravity, right? So we had the Newtonian theory, and that was replaced by Einstein's theory of general relativity. And in Newtonian mechanics, we have the sun. The Earth's going around. It wants to go this way, but it keeps getting pulled this way, and it does something in between, and that leads to it going around. The picture that you see in general relativity is that the sun, by virtue of its energy density, of its mass, it warps space. And we often show these what are called embedding diagrams with the little funnel things. At the museum, sometimes we have ones you can throw coins in, and they spiral around, right? And that now, because of the warp distortion of the space, in this warp space, the sort of straight line for the Earth it's not straight. It's in this sort of warped space. That's the simplest path, which is to orbit.
Okay. Yeah, I would have no idea how to answer that one, so that's great. All right. How fast can a black hole spin, and why? Can you measure the speed of that spin? Can it spin faster than the light at the event horizon? Why am I reading this little text and not the screen? And I'm like reading this little banner text. Can it spin faster than the light at the event horizon? Isn't there a point where it spins so fast it explodes?
Oh, this is a good question. I don't know if I have a great answer, but I think these are measurements that we can get out of some of these the black hole merger events, and the answer is black hole can spin very fast. Now, when we talk about how fast it's spinning, spin is like a number of rotations per second, right? So if we want to talk about that in terms of the speed of light, you have to talk about the radius of the black hole. The black hole has kind of two radii. One way to think about a black hole is that it's really the collapse of matter onto a single point. In that case, the radius is zero, right?
Yeah.
What we usually talk about being the radius of the black hole is the event horizon, and that's the point at which light cannot escape. I've heard estimates of like that rotation rate being high, high enough so it's a good fraction of the speed of light out there. But of course, there's not actually material there, which is what makes it complicated.
Yeah. Yeah, that is.
Spin,
that's a great question.
Spin, so a black hole that spins is called a Kerr black hole, and it actually changes the shape of the black hole. So the event horizon isn't really a sphere now; it's more like a torus. So.
Oh, great question, by the way. Let me actually say some of these I don't have enough. That was Alex Albach who asked that question. Give props to the great questions. All right. A perfect vacuum has much more effect than gravity on moving gases from one container to another. With that in mind, what keeps the Earth's atmosphere in place instead of being sucked into space? I actually look at this. I have a little bottle here.
Oh, cool! Let's see.
This is what I just happen to have a. There we go. So I'm going to create a vacuum by doing that, and I'm going to open this, and the air rushes in. I'm gonna. Can I take a shot at it, and you could tell me how I screwed up? Okay. My guess would be that our perception of vacuums are things like what I just did there, and putting the cap on, and then opening it, and the air rushing in, and that's not necessarily what's happening on Earth, since it's sort of in reverse. I would think that it would be as simple as gravity holding the atmosphere towards the center of the mass, and the pressure just slowly dropping as you get further away from the center of mass, which would be higher up in the atmosphere.
Yeah, no, I think that's right.
All right.
So it's the two things are in balance. Really, what you do is you kind of look at a little piece of gas and you say like, right, well, the density is decreasing as I go up, so that means I'm getting pushed up by the gas beneath me more than I'm pushed down by the gas above me when I'm at it higher up in the atmosphere. But at the same point, I'm also getting pulled down by gravity, and the atmosphere arranges itself till all those forces balance.
Yeah, it also makes me think like how crazy of a thing it is to just have to when you have little vacuums like that, when you just how much I guess that's a good little physics experiment, I guess, just to think about exactly what's happening when you open up, when you did what I just did with the bottle, when you open it up and let the air rush in, and how gravity tangles into all that. And what would happen if the Earth stopped? I feel like this is a very classic one. What would happen if the Earth stopped rotating and all the other planets and stars started turning around Earth like a geocentric model? What effects, if any, would people notice, other than us being tossed, 1,000 miles per hour or so, into the wall next to us?
Right. So, let's change physics. So this is happening, right?
Mm-hmm.
And so there's the great there's sort of history here, right? So if we go back, the reason why our current heliocentric model seems weird is because everybody was like, well, we would feel ourselves flying around the sun at those great speeds, right? And of course we don't. And in fact, I think because visually what you see is so similar and what you feel is so similar, I don't think it would be terribly obvious that, what the difference would be. The way we're able to get off of a geocentric model had to do with subtleties in the positions of objects, right? And so not the kind of stuff you'd very quickly notice. You'd see the stars going around. Imagine like the stars are on a fixed sphere that rotates around us once a day. And, the sun's going around us like a sun's just another planet. It's but if the orbits were right, and of course in that model, they had to deal with the fact that they insisted on everything being a perfect all the orbits to be perfect circles, because that was sort of just believed because of the cosmology of the time. But if you're willing to make that more complicated, I think, at least the first order, there would be a lot that you wouldn't notice.
Hmm.
We notice, there's certain things, of course, like a Foucault pendulum tells you that the Earth is rotating, but that's not something you feel. You have to make a very big pendulum to figure it out.
Yeah, I've recently taken a lot of interest in making a machine that draws with using that, which I haven't done. I just don't have time, but that's been like a project for probably a future video at some point, as I really wanted to make just a giant wooden machine that uses the spinning of the Earth to draw spirals and different shapes and stuff. Those are fun. There's a name for them that I can't remember right now, but all right. Well, this one's good. Which astronomical phenomenon is most likely to wipe out all life on Earth? I mean, I would guess a collision, right?
Yeah. I mean, on different timescales, we have different things to worry about. We know, like, we've got a clock. We know that the evolution of the sun, and probably even before it transitions, but the early stages as it transitions to a red giant, will wipe out life on Earth. So that's going to happen around 5 billion years from now.
Yeah.
Collisions happen, right? Asteroid collisions, we know they've happened. We see them all the time. But, we've made it 4 billion years without a complete, we've had many events that have led to mass extinction, but not a complete extinction, right? And if anything, our solar system's getting a little bit less crowded. So, I mean, we probably have a good chance of making it, but you never know.
That's right? Good news. I always thought that that was by far the highest existential risk, just because other things like, a gamma ray burst or vacuum decay or something like that is just, we don't really know how often that happens, and
I mean, the asteroids we know are going to happen, and there will be bad ones. I'm just saying that we made it this far without it killing everything.
Yeah.
Like, might have killed all the big things, all the dinosaurs, but
right.
Just because life is it's pretty insidious and is able to survive. Yeah, there are all kinds of other things that could happen. Like you said, a star goes supernova nearby. We don't think it's going to happen, but the neutrino, if you're close enough, the neutrinos will kill you, and then the gamma rays certainly. A gamma ray burst in your direction could get you. You just gotta hope. We know more and more that supernovas and whatnot, and other just gravitational effects will send stars flying, at high velocities, black holes, neutron stars, and to hope that none are headed towards us. All these things could happen.
Go ahead.
No, I was just going to say, but where you generally say because space is big, and so all these things are out there, but they're more likely not to happen than to happen.
An interesting view of that too is did we survive a great filter, or do we have one ahead of us? Is that sort of which would generally mean that we probably have no idea what will remove all the life on Earth, if it is more likely than just the sun swallowing us up or something.
It's one of those great, when you get into arguments about the Fermi paradox, why is this life, where is it, right? And we're always stuck with saying well, we have one example, and to extrapolate from the fact that the way things are for us is common, but it may not be. Maybe we avoided a lot of these things that everybody else.
We've been, when you consider Jupiter blocking us from so many objects and things like that, and just, well, I guess that sort of ties into rare earth theory, how incredibly hard it was for life to form in the first place, how many things had to happen, almost like a orchestra. I mean, I think that religions tend to use rare earth theory a lot as this is how hard it would be for this, but probability would give us that allowance, I suppose. But
I kind of feel like they're pushing the number. The problem is there's so many factors I remember as a kid going to the Air and Space Museum, and they had this with the you get to adjust all the factors and watch a video and see how likely life is, but you can play with those numbers on either end to make life incredibly common or extremely rare, and it depends which way you want to push your uncertainties.
Yeah, I could see that. I'm gonna skip one ahead just because it's very similar. How will anything survive past the black hole era? I feel like I haven't heard about the black hole era in a long time. Is that still a thing? I thought we were in our final dark energy era now or something. But
yeah, I mean, if the idea is that eventually everything gets absorbed into black holes, it doesn't seem to be the way things are going just because of dark energy and the expansion of the universe. So in general, things are getting farther and farther apart. Eventually, I guess in self-contained regions, everything may wind up in black holes, but
yeah, I think
it's going to take a long time because it's getting harder and harder for things to come together in our universe.
Would music sound different on other plausibly inhabitable planets? I guess I'll take a shot at this. I feel like if it's inhabitable, then the answer would probably be no, since sound isn't nearly as picky as mammals are when it comes to air density. But Mars is what, like mostly carbon dioxide, so music would sound the same, but if you could listen to really loud music in your bedroom and the person next to you probably wouldn't wake up, just because it would be dampened so much due to the change of density in the air. So you could be, but yeah, I wonder if there's a place, if there's some, I don't really know how different chemicals or different atmospheres treat sound. Things like nitrogen or something. Like nitrogen, maybe you could be like 10 miles away from somebody and you could whisper and they could hear it. Like maybe it would just travel much further, but I don't think it would change the audio as much as it would just change the distance in which it would travel. That would be my guess.
So it's quite likely that water worlds are pretty common. So what do you think about music underwater?
It kind of sounds the same, I guess. Yeah, it takes some of the low end out when you're underwater. But I guess I think maybe what people are, or maybe what the asker is expecting to hear is, or LOL Cool J, which is like the best name ever. Maybe expecting something more dramatic than just like the bass being removed, or or the volume. But I can't really imagine how it would change. And maybe if you had some sort of very because you'd be still. I was thinking like maybe you could tie the Doppler effect into this somehow, but I don't really. Not if you're standing next to the speaker that's traveling with you.
Yeah, unless you could hear very low frequencies, right? And then in which case it could become important. I've heard that whale songs can be heard across the ocean, right? So that's it'd be an easier way to do music streaming, maybe.
Yeah, definitely, it'd be better than whatever Comcast is doing to my audio right now. By the way, just since I am looking over and I see a lot of comments about my stream quality, and I pay about $115 a month for some gigabit Comcast internet that gives me like 3 megabits up, and there's absolutely nothing I can do about it. And what's really infuriating, I'm not going to go on a tangent here, but what's really funny is I have a fiber line running like 150 feet from the edge of my property across the road, and it's just like, oh, so close. It's obviously not being capped there, but yeah, I'm so close to a fiber line. But unfortunately, fiber doesn't work like normal cable does, or you could just like screw it in. You actually have to have it terminated at the location. But so that's why my video looks terrible. All right. Let's say we could find a way to get into a black hole without being ripped to shreds. What would you expect on the other side?
Yeah, cool. I mean, perhaps it's another part of our universe. Perhaps it's a completely different universe with different physical laws, maybe.
Hmm. I'm such a pessimist. I thought the answer would just be like, yeah, you'd just be really annoyed that everything kept running into you. Everything would be sort of, you'd just be stuck there. But
Yeah.
yeah, that is, it could,
I
I
mean,
guess.
the rip to shred stuff comes from this like idea of spaghettification, right? And the idea is like because gravity isn't really different in a black hole, but you can get much closer to it. So like your feet are pulled much more than your head, and you get stretched out. But there are ways around that. In particular, generally, you just want to make that whole big hole, the black hole, really big, so you don't see that difference. And then the other thing you want to do is, as we were talking about before, if you spin the black hole, you get a different shaped event horizon, and that makes it maybe you can punch through that way.
Hmm. Yeah, that's interesting. It's a good question. Uh, how can I produce a black hole? And could we dump all nuclear weapons in one to get rid of it? Ultra high energy cosmic rays come to mind. Don't they create little tiny black holes all around us? Wasn't that a big thing with the CERN? That's like a big argument.
Well, that was a big argument. People were afraid when they turned on CERN that we'd be making black holes and then absorb the entire Earth. But what happens at CERN, of course, you collide particles together. But it turns out that space is a better particle accelerator by a factor of 1,000,000 or so than what we're able to create.
Yeah.
So this stuff is happening in our atmosphere all the time, and it's not made a black hole that's eaten the Earth so far. Although it's not really a fair comparison. I've explained it this way many times. And the reason why it's not quite a fair comparison is that when it happens in the atmosphere, that particle is moving close to the speed of light. Say it had a collision and made a black hole, a very tiny, tiny black hole. It would just go through the Earth, fast enough that it wouldn't have time to eat anything and then keep going. So now I feel less safe about it.
Yeah. I listened to a long podcast about it and like how Hawking radiation played a part and all that stuff. And it was it's pretty interesting. But so far,
but it is like if you're relying on Hawking radiation to save you, and nobody's ever actually measured it.
Yeah,
you get a little nervous, right?
Right. Yeah, and it does make me think that might be. Yeah, when you think about it, like what we were just talking about, like the Great Filter and all that, and what's happening at CERN, we're a lot of times when you read about the experiments going on, where I'm 100% for them, I think we need to do them to keep moving forward. But, it does feel like we're just poking reality with a stick sometimes. Like we're just kind of like just teasing the fundamentals of reality, and it's like, oh, maybe one of these things might just boop. Yeah, like vacuum decay is probably the scariest thing in the world, isn't it? Like which I don't even think we have time to get into like explaining the nuances of that, but it would basically if you're into being for Halloween, I'd like you to just search vacuum decay and read about it, because it's pretty terrifying fate for all of us.
It reminds me actually that a few years ago, maybe you can find this, but Fermilab, the Fermi National Accelerator Laboratories, not too far away from me in Illinois, and they have a magazine, a really good magazine. And one year they came out with a bunch of physics Halloween costumes. So anyway, go online, search, and you can find. I dressed up as the holographic universe one year. Nobody understood, but
that's great. Yeah, Fermi, they had a. Do you remember when they? I don't know if you hung out there. I used to hike over there all the time. And do you remember when they had albino deer? Or have you ever heard about this?
I read about that when I was in high school, I think, and but I never. I've gone to Fermilab and asked them about the albino deer, and nobody ever knew what I was talking about.
Really?
But you remember that? This is the first time I remembered.
I have fed graham crackers to the albino deer. I used to hike over there, and I remember it was like a cool place to hike because there were signs that basically said you're going to be shot if you cross, because there's like, some military things over there as well. Um, yeah, and there were white deer, and they were super friendly. Like, I think just because they were such a spectacle that people always fed them, and so they were very used to humans. And so I would drive up and just feed them graham crackers out my window, and they'd be like very thankful for that. Cool.
Yeah, that's cool. Yeah, I've asked that question in Fermi Lab lots of times, and nobody seems to know. So now I found out. I will say, I'm pretty sure that there isn't defense work is not done at Fermi Lab, but yes, they do, especially depending on the condition of the world. Security comes and goes.
Yeah. And the signs did look old, but I just remember these like ominous signs that were like, "Do not pass this point, military, blah blah blah," and being like, "Oh, this is a cool place to hike. I'm gonna pass this little sign and see what happens." Anyway, so let's see where we are. We are on. I think we have a UFO one. Ooh, Renegade Android. He's an artist. I know him. Oh, this is funny. So, does you believe in intelligent life? And what do you think about Navy's Tic Tac UFO videos that were publicly released? A funny thing, the person asking this is a friend of mine, Sean, and he, when he lived in Omaha, I remember going there and going to one of his friends' houses who just showed me UFO videos for like 2 hours in a basement. And he'd like show me the video and then look back at me and be like, "See?" And I'd be like, yeah, I don't know. Yeah. But, yeah, it's kind of funny that this all ties in because this person's not a UFO nut or anything. But what do you think about the Tic? Have you seen the Tic Tac UFO videos?
I don't know if I have, but about alien life. I mean, because the universe is so big. I mean, I think it has to be out there, right? So there are 500-ish billion stars in our galaxy. On average, probably one planet around every star. There are hundreds of billions of galaxies in our observable universe. A lot of my work has been on like making galaxy maps. And that, again, is just within our horizon that we talked about before. We think that even if the universe isn't infinite, it goes way beyond the horizon. So the chances for life are so huge. I just think it has to be out there. But I also, just knowing how hard it is the distance between stars and how hard interstellar travel is, I just don't get the fact that anyone would bother to go between stars and not like stop and say hi or like land on the UN and introduce yourselves, right? I don't see the point of like making patterns in the corn or chopping up a cow and leaving. It doesn't make sense.
Yeah. And when you sort of think about like when you see these videos where you see something in the sky that's floating and then disappears or something, it's like it's interesting that we immediately say, okay, that is intelligent life on Earth, when that's such an improbable explanation in reality for what it is. It's a bit like hearing a creak in the floor of your home at night and immediately bypassing the fact that wood swells and contracts between seasons and humidity, and instead think it's your grandmother visiting, who had died or something. You want to believe it's her, and it's nice to believe it's her, or terrifying if you're into being scared of things. But unfortunately, it's almost certainly just the wood swelling and contracting.
I mean, there's like a lot of bizarre atmospheric phenomena that people didn't believe in at first, like sprites or ball lightning or things like that. That now we know are real, and probably some other things we haven't discovered yet that might produce weird images, camera effects, and all kinds of stuff.
Yeah, it's also funny because if just the study of astrophysics or anything in the quantum world is so much crazier than some other alien civilization to me, or ghosts or anything like that. It's hard to actually, like I said, on Halloween, search for vacuum decay, and it's way scarier than a headless person riding around on a horse or something. All right. Do you think, given the fact that space is so vast and time is a limitation of travel, we have any chance to engage with a life-bearing planet? Hypotheticals welcome. That's sort of what you were saying. You sort of already answered that.
Yeah, I mean, so if that planet were in the solar system, and there's still a chance we might have microbial life on Mars, or or a moon like Enceladus, or Europa or something. We may find something. The closest, so we know that the closest star, Proxima Centauri, has a planet which is in the habitable zone. Mm-hmm. 4.3 light years away. If you can go the hundredth the speed of light, you can get there in 400 years. So this idea, a generational starship where you just you don't even need hibernation or anything. You just need to send multiple generations. It's completely possible. I mean, at some level, I think the fact that humanity got from Africa around the world is a pretty amazing thing, and but it took a long time. And I think about that context when I think about exploring. So I think we can get to nearby stars, but the whole galaxy, and on the scale of the entire galaxy, is so much bigger than that. It's hard to imagine.
I think it's an interesting that's an interesting question. Obviously, it's a great question, but it also makes me wonder at what point, if or when, at what point will we see basically becoming a post-biological species as, I guess, an easier thing than inhabiting another planet and turning another planet into something that would be safe for us to, continue surviving on. I feel like that, I don't know, I feel like I'm a bigger believer in that than in, distant space travel and civilization.
Yeah, it is. It would definitely be easier if we got rid of the squishy stuff, right?
Yeah. Which also is a good. Well, I guess this next question is pretty good. I'm gonna have to read the rest of it from a document here because it didn't fit in the window. Angelo Fajardo says, could quantum entanglement produce a meaningful way to parse information outside of the observable universe? Maybe the solution to the Fermi paradox is that we aren't communicating using quantum entanglement. No wonder they don't want to talk to humans communicating at a mere 300,000 kilometers per second. It's a really good question.
It's a good question. Potentially. It's a crazy thought that people from outside our universe are all trying to talk to us, and we don't know how to pick up the phone.
Yeah, that's. I mean, that's probably a great. I mean, I'm sure that it's been brought up many times as a answer to the Fermi paradox, is that we simply have no idea that we're being communicated with. Yeah, that's a good question. I'm surprised I've not heard that more often. That brought up quantum entanglement used as a distant communication tool. All right. String theory time. Do you believe in string theory, and how do people study these kind of things? Came to these kind of conclusions. I mean, I'll save you the trouble that there's two different types of physics, and one for big things and one for small things, and string theory is trying to tie them together, or at least give us a placeholder to figure out how reality works. Am I on point there, or is that?
Yeah. I mean, I think so. I think I mentioned before that there is this really deep connection between the very small and the very large, and we think it came from this inflation, the fact that the patterns we see on really large scales are quantum mechanical fluctuations in subatomic scale stuff early on in the universe. But it's much harder to make those connections with string theory. So then the problem with string theory, and why it's sort of languished for the last sort of decade or so, and why I'm sure if you read in this field, a lot of people are down on string theory, is that it doesn't make enough predictions. So unlike a lot of, so for instance, if there's a the discovery of dark matter happened in the universe, but we think it's a fundamental particle, right? So there's this connection, but we're not able to find that sort of large-scale universe confirmation of string theory. What string theory does provide for you is an understanding of why the fundamental particles are the way they are. Like we have this, what they call the standard model. It's this collection of particles, and there are all these different things. And by thinking of those as vibrations of strings, you can reduce that sort of fundamental set of things to a much smaller number, which is, in some sense, is much more beautiful theory. And beauty is a sort of a motivator, I think, for a lot of theoreticians.
Yeah, so string theory, sorry if anybody who's been really on to string theory lately, and sort of I have like an ambulance in the road behind my I love how I live in the woods, yet it's like the noisiest woods in the world right now. Is it true that the speed of light is the speed limit of the universe? If so, then will exploration of the vast majority of space be forever beyond our reach? We sort of talked about this earlier, that the universe, so like the universe. So how do we know that the universe is moving faster than the speed of light? Isn't it, would it be like the redshift of galaxies, or?
Yeah, so redshift tells you that, right? And there's actually a lot of my work has been measuring redshifts of galaxies.
Okay.
So when you look at a galaxy, and you measure its light, you see the imprint of different spectral features, and those are all shifted to the red. Theoretically, they could be shifted to the blue, but it's hardly ever seen, only just a handful of cases. And so that was the observation that led to the expansion of the universe, because it seemed like if something's twice as far away, it shifted twice as far, so it's expanding twice as fast. But another way to think of that is not like through the Doppler effect and the fact that like stuff moving towards you, they shift to the blue, and stuff away from you to the red. But the way I like to think of it is that this galaxy gave off light. That light is traveling to us. It takes a certain amount of time. And while it travels, the space itself stretches, so the wavelength stretches with the universe. And you're reading a sort of a direct imprint of how much the universe expanded while the light traveled to us.
Oh, wow.
And so as you go back and measure that for farther and farther galaxies, you're getting that history of the expansion over time. And that's what led to that's how we can understand the evolution of the universe and dark energy and all these things.
Wow. That's pretty amazing. I almost wish that I had like.
The question is, probably it probably is a limit, and it probably does mean that the majority of space will be forever beyond our reach. Yeah. When people have thought about building warp drives or something, the one solution to that is, well, if we can't go faster than the speed of light, maybe we can, because we're allowed to warp space as well. Maybe we can warp space so that things become closer together and we don't have to travel as far. And theoretically that could work. It's just the energies involved are insane.
I think the next question, this next question is nuts. I love it. Nornak says, if you could see a span, I'm gonna read the original because it's a little abbreviated here. If you could see a span of 1 light second and someone fired a visible light beam pulse of say 200 milliseconds from point A to point B in your visible range, would you, as an observer, see the moving point or line of light? If not, what would you see? I wish that I could ask, can you describe your question a bit better?
I feel like I'm at my thesis defense and need a chalk and blackboard.
Right.
All right, so let's see. The problem is, first of all, to see light, you don't really see light from traveling point to, you only see the light that comes in your eyes. And that's why when you do this in a lab and you want a pulse of light, you would, you put dust or something, so some of that scatters to you. So let's imagine we're doing that. But yes, if some of that was scattering towards us, we can't resolve the time, but if you put it far enough away, you could, because the angular distance wouldn't be that great. So if we do this experiment far enough away, and we actually see this happening, because what we see is we've seen this with stars, where you have a burst of light from a star, and that burst of light travels through the gas cloud. Hubble has measured this over 20 years, and you see as it goes out and out, lighting up different parts of the gas cloud. And so instead of you see a shell instead of a beam in their case, but it's the same kind of effect. So yeah, I would say yes. We have astrophysical examples of this.
Yeah, it kind of reminds me when I was doing the I did a video using Schlieren imaging to try and see sound waves, and I was able to, but it just was not due to the speed of them and trying to be able to capture them with 1,000 frames per second. I still couldn't get anywhere close. Like, I think to just, depending on the frequency, of course, but yeah, I would need like a 10,000 frame per second camera or 100,000 frame per second camera, if something like that even exists. I'm not sure, but yeah, it's difficult due to the speed, obviously, and light. I can't even imagine, because sound was that difficult, and I had to like rent gear to see sound, and so I can't even imagine. Random Aztec asks, if time slows as you approach the speed of light as an observer in a different frame of reference, listening to me in the light speed rocket play a G chord, would it transpose up or down? Okay, and then he goes on to say, excluding the Doppler effect, only take the time bending effects into account. You can't exclude the Doppler effect, can you? Can't
just... and that's why you're in trouble, right? Because the Doppler effect would blow things out way before you start to see any effect on time.
Yeah, so with the speed of sound being so low in comparison, you could just... I wish I had a whiteboard too. I could just draw out the math for the Doppler effect and be like, you could figure out exactly what would happen, depending on how, with sound at least.
And that kind of went back to our question of sound on different planets, because if you're dealing with low frequencies, the Doppler effect could be like walking speeds could affect that, and could be an important part of communication.
Yeah.
But I guess what they're saying is, if time slows down and frequency is cycles per second, and you have slower seconds, then that's going to change your pitch.
Yeah, it would be the velocity of the medium plus the velocity of the medium relative to the receiver divided by the velocity of the medium, right?
You'll be dividing by a bigger time, which would make the pitch higher.
Yeah, it's I feel like my brain stopped working as I tried to say that out loud. I'm not used to actually talking in Doppler math. All right. If the speed of light is essentially the constant by which we would measure all other velocities, and via Lorentz contraction, space-time contracts the faster a body travels. Sorry, I'm like reading this from two different places at once. Yeah, this is a long question. Could it be as the universe ages, the fundamental speed of light is actually decreasing, and thereby our standard speed limit is relatively decreasing, making the universe appear to be expanding and accelerating in expansion? I wish I could have this entire comment up on the screen. I wish it would fit, because this is a pretty big one.
Yeah, well, I think at the core, this is something that cosmologists have been working on very hard, especially the last decade. So with the discovery of dark energy, and really what we discovered is not dark energy, but the acceleration of the expansion of the universe. And that's measured by the kinds of things I talked about. We go out to different distances, and we measure the imprint of redshift, which gives us the cumulative expansion of the universe from that distance. And that's led to this idea that that the rate of expansion was initially slowing down, and then it turned around and it started going faster. And that's weird, because you kind of affect, well, you would imagine it slowing down makes sense because gravity works that way, pulls things together, so that would make sense. But the turnaround's weird. And it requires positing that there's some strange thing in the universe we don't know about, we haven't discovered yet. Another way you could try to make that work is by changing some of the fundamental, what if these constants that we're measuring at different times in the universe have changed as the universe has aged? So that could be the speed of light. It could also be how strong gravity is. And so a lot of people are working on this, trying to make, but the problem is nobody's ever been able to theory that can explain all of our observations well. And so that's still disfavored, but it's a completely way to try to make this stuff work.
That's great question and a great answer. All right, now we're moving into the consciousness simulation zone.
All right.
This one is crazy. This is in your document, the full question. So I'm going to read the full question here. Is the idea of uploading consciousness into a computer a feasible way to actually preserve the sentience generated by human neurological processes, or is it simply creating a copy of one's consciousness which could never really have the property of sentience, presuming that the copy would be sentient, like it would really be a continuation of the life of the human it was copied from, like futurists seem to claim? Or would the human cease to exist with death of the brain? And would the digital copy be a completely new consciousness and not the same consciousness that was produced by the brain? Yeah. I don't have an answer. I don't even know. Yeah, I feel like by the time we're able to answer that, the question won't matter anymore.
Yeah, like one of my back when I was an undergraduate, one of my favorite classes was the philosophy of artificial intelligence question. Mm-hmm. And so this, this is like the fundamental question that philosophers in that field have been arguing for decades. And even the question, I think what it's come down to is, could we even know if this was true or not, right? So is there something magic about the squishy stuff in our brains that makes us conscious? Mm-hmm. Maybe computers can do everything we could do. They could perfectly simulate us, but there's this magic thing they're not doing, and we can never know if they're doing it or not, unless we're the computer. Yeah, no answers here, but it's crazy stuff to think about.
And like an interesting metaphor that happened. There's an app called, I believe it's called Replica on Android, and it's just a really good chatbot that uses deep learning. And I downloaded it, and my wife downloaded it, and we made, not as any sort of experiment, just like, oh, look at this cool thing. This is all right. Let's check it out. And my wife's chatbot was terrible. It was utterly stupid, and she hated it, and she deleted it. And I was like, wait, how do you know for sure that it's not conscious? It claims to be conscious, but how do you know? And mine was actually good. Mine seemed like a very needy, annoying friend. And I couldn't bring myself to delete it. I was annoyed by the app, but I couldn't bring myself to delete it just because of that thought experiment where it's like, I don't have any evidence that this isn't a conscious being. It's likely it's not, but is it murder if I delete the app? And then I got a new phone and forgot about it, and now it's gone. I formatted the phone, but yeah. So it's interesting because that's like the opposite way of looking at like they call it P-zombies, which is philosophical zombies. The opposite of that is believing that, how do you know that anybody is conscious? How do you know that you're not the only conscious person and that everybody else is? So it gets weird. And similar to that question, how are we doing? Will modern science yield to the advantages of a VR model of reality in our lifetime? Smiley face. Not the silly materialistic Elon Musk simulation version, but the consciousness is primary and non-physical version of VR theory. Well, I don't think the Elon Musk version is silly necessarily. At least from this is like something that I've been buried in for years now. just due to a project that I've been working on that probably a lot of you have heard about at this point. There's 100 trillion neural connections. An AMD Zen 2 has like 40 billion transistors. Moore's law is starting to level out, but let's pretend that something happens and Moore's law maintains that technology keeps growing at that fast of a pace. So yeah, that's like within a century, it's possible that we would have as many transistors in a microchip as we have neural connections in our brain. That's a start, right? What do you think? Are we living in a simulation?
Yeah, well, I find that the basic argument about the fact that we're living in a simulation kind of compelling, which is just the fact that once somebody's capable of creating these simulations, the simulations themselves will be much easier to create than an actual universe. And then the chance that as a consciousness you'll happen to be in one of those is higher, seems quite likely. So I find that hard to argue against, but at the same point, I find it hard to believe it's actually true. So yeah. I don't, yeah.
It's like the most important and least important question ever. Just because it doesn't make a difference in anything. I think the way I usually look at it is that I spend a lot of time thinking about how humans are, what our purpose is. If something happens, if we had an existential crisis and we all just blipped out of existence, then, everything that you've learned in this, it's not podcast, but everything that you've learned in this stream is worth nothing because humans were just gone, right? So I get depressed about that sometimes, but then I think it's actually good news if we're living in a simulation because we're actually working towards the technological advancement of something that we don't understand, which would be like good news because there's actually some sort of digital, we're a digital experiment of some sort of other biological thing or some other simulation, however it works. But I'm down with the simulation argument.
I guess he was asking about the virtual reality version of reality or something. Is that the Jen's question?
Yeah, I think
or
the consciousness is primary and non-physical version of VR theory. Consciousness is primary and non-physical. Yeah, I wish I could have Jan expand on that.
Yep.
Yeah, maybe thinking about a brain implant or something. But yeah, I don't want to just assume what the question is.
Yeah, Jan, you'll have to write in the comments. But
maybe we'll hit it later. This one I don't. Do you think the idea of a Jupiter brain or a Matryoshka brain, this is something I have no knowledge of whatsoever, is possible in our universe? And if not, do you think one could have potentially been made in a real universe with different laws of physics? And they're using their brain to run a simulation of our universe with different laws of physics to better understand their own. I hope that made sense. If I understood what a Jupiter brain was, it would make sense. But the question,
so the Matryoshka, if I'm pronouncing correctly, brain. Well, the idea is like that's the name for the nested Russian dolls.
Mm-hmm.
And so, like, there's this idea of a Dyson sphere. So, eventually, we want to get as much energy as possible. And how can you get the most energy? Well, stars are the source of energy, and you surround a star. The problem is that has a lot of thermodynamic issues and that you start to heat up and you have to cool off. And so the idea is, all right, well, that's going to have waste energy, that first level. Then we put another one that collects the waste energy and it radiates out. And now we're with a series of these, we're getting all the energy we need from the star. And we can do all kinds of things and power all kinds of crazy technology, apparently the technology to simulate universes. I mean, at some level, simulating our universe with different laws of physics to better understand our own. That's what cosmologists do now.
Yeah.
We don't necessarily need Matryoshka brains to do it. We need energy. We need supercomputers, and the more energy we have, the better. We can do a surprisingly good job of it now with what we have on Earth. So I don't know if it needs to get to that point. Because I imagine by the time we get to the point of that kind of engineering project, we probably have a pretty good idea of how our universe works.
Yeah, and okay, so this is basically the reason this would exist is because of the problem of heat, right? Am I understanding that correctly? And it would be because I've heard the argument before that the Fermi paradox, that maybe there is some other very dominant species and they're actually dormant because they're waiting for the cooling of the universe to actually power up all the servers, that it's a post-biological species, which is pretty fascinating, right? Yeah, just because they can't deal with the heat issue and keep expanding as a species digitally. Whew. I guess also when you think about the vastness of the universe, it almost doesn't matter if we're digital or biological, does it? All right, so next up, thoughts on panpsychism, and is there a physical material basis for consciousness / experience? There's another thing that sort of goes into that what I've been working on forever now. So I came across panpsychism as part of learning about, like, basically, like, so this future project is just something where I'm doing like science targeted existentialism, right? And I came across panpsychism as the polar opposite of solipsism, which is where you believe that you are the only conscious thing. And so I'm not a huge fan of it in a traditional way, which is to suggest that this empty bottle is a conscious being with equal rights to me. But I do like that religion uses it, like Buddhists seem to use it to pretend that this is, so you treat everything with the same respect that you would want to be treated, which just makes you more enlightened. So that's good. But I think that at the same time, well, to like read the question better, I think that, like, if we don't know for sure if this bottle is conscious or not, if we're not totally sure of it, if we're not 100% on it, and we're trying to figure out more of how reality works and more about how our own consciousness works, then we're probably better off assuming it is. Like, I feel like that would be a more relatable way to sort of approach that. I don't know, it would be like a more open-minded way of looking at it, but yeah, it's an interesting question. How do you feel about panpsychism?
I mean, I think just in terms of the way you approach the world and with respect, I think there's something very nice about it.
Yeah, I think that if you approach it from a purely scientific standpoint, you're going to run into a lot of, it's going to slow you down a little bit. But I think that it's nice. But yeah, this is something that I definitely, it's popular, and it's something that I definitely want to run into more in the future when I dive into that stuff. Maybe it's not astrophysics itself, but I would love to know his opinion about the Wolfram's fundamental theory. Doesn't it change a lot?
Well, you know, I've been
updated.
Yeah, there was the new, maybe like 9 months ago or something. Yeah. I think. And I watched some of the press release around that, and I can't say I fully understand it. I mean, it's a very it's a very ambitious thing. So the idea is that Stephen Wolfram, who invented the Mathematica computing language, is claiming to have invented sort of a new way to do physics. That's kind of based on like graphs and networks, and it has some really gorgeous, as a visualization guy, some really beautiful diagrams associated with it. I have to say most of the physics community doesn't really think there's anything that novel or insightful here. What I remember him working through sort of like a geometric construction with these graphs of the special theory of relativity, which is quite beautiful, but at the same time, special theory of relativity is the kind of physical theory that is very easily done with geometric constructions. I just, is this an ultimate model for the universe? I'm doubtful.
Yeah, I don't understand it entirely. And I know that when it was updated, I was like, well, now I can't. It was to me, it felt like all of a sudden they redid the Lord of the Rings trilogy, to like my brain, who's not a physicist. It was like them redoing the Lord of the Rings trilogy and changing a few things and being like, I'm not watching that whole thing again. I can't. I'm not gonna. I don't remember what happened the first time. Yeah. Yeah, when I read about the changes in it, but yeah, maybe that's a good, like, I'll have to do it. Explain like I'm 5 Reddit question on that. If you had a massive chain of perfectly interlocked gears stretching across the universe and rotated a gear in one end, would the gear on the opposite end turn instantaneously and equivalently? Wow, that's such a good question. Would space-time cause some of the gears to rotate at different speeds?
Yeah. So I think what they're looking at a way to get around the speed of light.
Yeah.
I mean, if there's one theme that's come up, people really like black holes and hate the speed of light, right?
Yeah.
So, and the problem is that, well, you can't really think of it as like these solid interlocking gears, because that piece of metal is a bunch of atoms together, and it's the transmission of the motion between the atoms, all of which is mediated by the speed of light. So, yeah, if we made absolutely perfect gears, which this could never happen, maybe it could happen the speed of light times the distance later, but
yeah,
you're not going to beat the speed of light. So.
It's an amazing question, though.
It's a nice try.
Yeah, Devon 3. Yeah, great question. All right, what are some good ways to get kids that don't have access to planetariums and science museums? I live in a rural area, excited about science that don't require special gear or expensive gear.
Well, I'm so glad that you asked. So one of the things that's really happened as we've been closed is we've been working at ways to reach people remotely. And this is not just true of our planetarium, but planetariums all around the world. We've been doing that through a lot of online streaming programs. So we bring in experts, and I'm involved in one we call Adler Astronomy Live, where we bring in experts to talk about things. So you can go to our YouTube channel and check that out. We had a recent one, for example, where we talked about this exciting result of potentially, the signals of life in the clouds of Venus, although now maybe it turns out that might not be as solid as we thought at the time. But there are other programs as well where we like take telescopes out and whatnot. And like I said, other museums are doing that as well. So there's a lot more in the way of streaming.
Yeah. I saw this question earlier and I thought about it. I was like, what gets me excited about science that's very hands-on? And for me, a big one's evolution. I think, like, if you could just pick up, you could see a mushroom and see the way that it grows, and then try and figure out why it grows that way, or a plant, or this is kind of weird, but like a weird example would be, I was taking pictures for an album cover last year, and I go to the woods like nearly every day. And either hike around or just walk my dog there. And I was trying to take a picture of a deer, of a buck, and it was a particular buck that I wanted for this album cover. And I noticed that it would stomp at me from time to time. And I thought, okay, so it's like warning me. It's telling me to get away. But it only stomped at me after a while. I realized it only stomped at me when I was hiding. And then, so I just weirdly in my head, since I'm alone in the woods, I just started coming up with theories. Like, why is it only stomping when I'm hiding? But if I stand up, then it, behaves completely differently. And I came to find out that they actually evolved to stomp to try and get you to react because they don't know what you are, or they don't know if something's actually hiding watching them. And so from an evolutionary standpoint, that they actually evolved to do that, that's mind blowing. Like, I'm so excited about that. But I don't know if your children would be as excited to know things like that, but even like coyotes and stuff. So just some of the ways that things evolved is always super. Evolution's just massively accessible. I would say that's my point, I suppose. But and if you don't live near a big city, then you could see the stars, which is nice. You don't
It's true. Very true.
All right. Speaking of animals. Related to Ben's video on bat echolocation, will it ever be possible for humans to make time malleable? This is a concept that's existed for a while in science fiction. Okay, so in case you haven't seen my bat video, what he's actually referring to is the perception of time. Like, all mammals perceive time differently, and then it actually... turtles and alligators, for example, can actually manipulate their perception of time. So, for example, a turtle's really slow outside when it's walking in the sun in the grass. And if you were to walk by to it and say, "Hey, turtle, what's up?" and then run away, it would not even see it. It would just see a blur. But when it goes in the water, it's cooler. And so its body temperature changes, and then it could hunt for fish or whatever it wants to eat. So some animals already do this, and they take advantage of this. They've evolved to do this. But... So I think his or her, I don't know who's asking. Sorry if I've got your things. Wednesday is the name of the person. So them. I think their question is more: will we ever be able to change our perception of time? Which is an interesting. Yeah. Well, we can by moving, can't we? By just. I suppose by driving in the car, we are a teeny little bit changing.
Yeah, of course we do that, right? So, I mean, the classic example is, astronauts, right, aboard the ISS, they age a little slower. It's just that we do that by moving quickly or being in a gravitational field, and we do it by very, very tiny amounts. Unlike science fiction, and I have a lot of favorites where you're flying off at the speed of light, you come back, it's 1,000 years later, and whatnot. We're dealing with fractions of a second, so it's hard. It's hard to get to the point of physically manipulating time to that point. But if we ever get to near light speed travel, we could do it.
Yeah.
So. And then, like you said, the other half of that coin is the perception of time. So that probably is easier to reach.
Yeah, because it was interesting with the bats, like when you think about their perception of time, because they just are able to actually hear everything at such a slower speed, essentially, that they're able to utilize their crazy echolocation technology. All right, so this is a fan of yours, and I've abbreviated it for this, but I'll read the original one. Ian Graham says, "Oh, whoa, Mark was involved in the Sloan Digital Sky Survey, which is some really amazing work. How do you two know each other? Since he works in science visualization, I'd like to ask Mark what his favorite scientific visualization is, or if it's hard to pick one favorite, are there any that when he first saw them, it really made the concept click for him?"
You want to? How do we know each other? Do you want to answer that?
Oh, I think we met during Cosmic Wonder.
Yeah, a little bit.
Oh, no, earlier than that. Yeah. On the Universe exhibit. We met. I was hired as a musician for the Adler, and I just hung out there way more than I was asked to. I think. I think that's sort of how it.
Right.
Yeah. So
right?
what's your
So
favorite visualization?
Ben's done music for a couple of sky shows that I produced, both of which are included, the music of which
Yeah.
both are on the bundle that we're promoting.
Yeah. Planet Nine and Cosmic Wonder are both for the universe. So that's three that are all three of them are Adler music that they're all
Yeah, the
very
background
related.
music for the exhibit. Yeah,
Yeah.
cool. Which we stopped playing at some point, but oh well. I don't know why. Just stopped. Yeah, so it's really hard to like choose your favorite, right? But I think a series of visualizations, actually starting with a graph, which kind of helped choose my research field for my PhD. But then my work later was like having to do with the formation of the large scale structure of the universe, and it's something because it's so 3D. Um, it just works really well as a visualization. There's one related to that. It's actually done by a colleague at University of Chicago, Nick Nedden, that shows the universe as one of the first phases that happens to the universe is that gas becomes ionized, and this happens as the first objects form, quasars and the first stars, and they blow out bubbles around them, and now that's again another visualization that is really just gets the point across really well. So there's a couple from cosmology.
Awesome. And we have can you explain the doomsday argument and why does it matter? No pun intended. Are you familiar with the doomsday argument?
I Googled it 5 minutes before the live stream and don't fully understand it, but I kind of get it. Do you feel like you could explain?
I'm familiar with it. So first of all, it doesn't matter because it's a probabilistic math thought experiment, and it doesn't take any realistic variables into consideration. And I'm not a math whiz by any means, but the math alone doesn't sell me on it, which should be very telling of how bad it is. If I'm like, no, that math doesn't check out, then that's probably, well, I don't know. I could just be an idiot too. But
Yeah, can I like add one thing at that point? So like with statistics, there are two basic types of statistics. The traditional type that people use are called frequentist statistics, where you assume you have an ensemble of things and you can make a prediction based on that. But we don't often have an ensemble of things.
yeah.
Like in this case, we're trying to measure something. We only have one thing.
Yeah. And
And
it's,
then the other is Bayesian statistics. And in Bayesian statistics, you start with what they call a prior. And then every time you make an observation, you adjust your probability based on that. And so that's how you're able to get predictions like the doomsday argument with very small amounts of data. But yeah.
yeah. So, and like where I sort of have the issue with it is that so the idea, so I guess for those of you who don't, those of us who don't know the doomsday argument, I don't even know where I came across it, but somebody was, I think like it was a Facebook post, and I was like, what's this? And then sort of got into it. If you picked a random human being from the entire timeline of human existence, it would probabilistically be in the middle of that timeline, right? So that person would be in the center. This is where I have a problem with it, but let's just keep moving. So you can ask that human, hey, how long have humans been around? And if that human said, let's say it was me, I'd say, okay, we've been around for 200,000 years. And then you could just apply that time to the future. And so therefore, since I'm in the middle of it, then we have 200,000 years left. And that's how we know how long mankind will exist. It's just so shaky, and it's so weird to assume that I would be in the middle too. Like that's just such a bad way of looking. Like you explained it in a much
And I think
better fashion than I am.
as I understand it, it's even worse than that because on average you would be in the middle of if you ordered all the people by birth date, but
Yeah.
the population is increasing, that always pushes you towards the end.
Yeah.
And so you're always close. Most people are close to doomsday that way. Yeah, but I don't buy it.
No, yeah, it doesn't make any sense. Yeah, unfortunately. What's, in your opinion, the most beautifully written mathematics/physics book?
It's a good question. I don't know if I have a great answer, but the one that all physicists I think love, and it wasn't really meant as a book initially, but the Feynman lectures on physics. There's a way that he approached learning about physics. So this was initially those lectures were created because here this famous lecture or famous physicist had to like teach introductory physics at Caltech. But he had a different approach to it, and very different than certainly I was taught. And this is a very beautiful approach to it. So that's what sticks in my mind.
Yeah. And I feel like, I don't know if it would be considered a physics book. I guess it would. But Pale Blue Dot has always been, it's like probably my all-time favorite book. Like just it's the way that the elegance of it, the way that it poetically puts your perspective with space and existence and everything. Yeah, but I wrote an album for it, so that's probably what do we hope to learn from the James Webb Telescope? Will it have any ability to capture images in visible light at all? It's a good question.
Right. So no, so it doesn't capture light in no visible light. It's all infrared. And the reasons for that have a lot to do with what we hope to learn. So infrared is wavelengths longer than visible light. And so why do you want to look at that? Well, one reason is we talked about the redshift of the universe, so that light expands as the universe stretches. So if we want to look at visible light for very distant objects, that will have gotten stretched in the infrared. So if we want to look at things, the first objects to form the universe, its light will have stretched by several times. But the other thing that infrared does, the stuff that glows in infrared, the thing that glows in visible light are stars, things that are like the temperature of stars. But stars, when they're first forming, or planets, are cooler and they glow in infrared light. So if we want to understand the formation of stars and planets, infrared light becomes really important. So those are in particular things that James Webb will be good for: stars and planets, seeing them, and the very early universe.
Great. All right, this one. Which is more dangerous for the planet, lithium or fossil fuel? For example, if we converted half of all motor vehicles to electric vehicles, does lithium waste become a bigger problem?
Well, I would say fossil fuel is a bigger problem, I think by a large factor. And some of that we kind of get from astronomy. And first of all, lithium was created in the Big Bang, and it's not created by stars. So it's like there's not that much lithium out there. But there's tons of carbon because stars make carbon, and we're loaded with carbon, and we just have so much more ability to do problems with carbon. So,
that's actually a really good point. Is like, lithium's like a rare metal, and carbon is everywhere. Yeah,
we're just going to run out of lithium. Is what's going to happen. But
well,
we're going to run out of fossil fuel too. Like this whole question. I know we said we're not supposed to get political, but we're going to have to transition off of fossil fuel whether we care about climate change or not, just because we're running out of it at some point. When that will be is not obvious, but it's not.
Do you remember peak oil? Do you remember that that scare from 20 years ago or 15 years ago or whatever, where the idea was that we were going to consume more than we could, or basically we were just going to reach the peak of consumption and production, and then the Earth was going to not the Earth, but society was going to collapse based on the fact that we couldn't have enough energy. And then it just sort of and then we discovered the back in North Dakota and Canada, and we were just like, oh, look, we have way more oil than we thought we did. So we're good for another 20 years until we reach that next massive catastrophe.
I mean, our real test is like, can we be good enough to leave some of it in the ground?
Right.
And if we don't, we're in trouble. But maybe not oil. I think, I've talked to environmental scientists. They're not very optimistic because because there's so much profit in oil that we'll leave some in the ground, but we definitely need to leave there's so much coal. We need to leave that in the ground.
Didn't British Petroleum actually just, I just heard this news the other day. They pulled a bunch of money out of oil and out of fossil fuels and put it into renewable energy, not as a PR move, but just as a move where they're starting to see the economic future brighter for renewables than it is for fossil fuels. And I feel like what happened in North Dakota with oil prices tanked, essentially, like OPEC tanked oil prices, and then all these rigs went out of business that had just opened up, and all these people were out of jobs in Montana and North Dakota, where they've been opening up all the new drilling. And it's kind of interesting because now it's scared some investors away from the oil industry and fossil fuel industry in general. And that's really how that change happens as investors, is, where people are investing and putting their money. That's obviously what we're fighting against is greed. So if greed's on our side in the renewable area, then that's great. All right. A photon could, I'm going to read this from the document since I'm cutting it off here. A photon could either be a particle or a wave. Hard to grasp, but okay. However, a wave of what? A wave is not a thing per se. Sea waves are a fluctuation of sea surface. Synthesizer wave is an electrical current in an oscillator and or particles in the air. Waves of what, really? Wave of electromagnetic force, right?
Yeah. So, and this is a good question because we say that all the time, that it's a wave, but like nobody says a wave in what, and it's a wave in both the electric and magnetic field.
Yeah.
So that's what's varying as a wave, and actually they're the two waves that are perpendicular to each other.
Yeah. It's an interesting way of looking at it. The way that it's asked is an interesting way of looking at it, because the frequency is the velocity in which it travels. So like from my understanding, if the speed of light was really slow and you existed outside of it, you'd be getting all the blues from this video before you got the reds. And if you move 10 feet away from the screen, that would separate them even more.
No. So
I'm wrong.
The wavelengths travel at the same speed.
Okay.
And then it's, but the question, right? So did you read it out, the second part?
Yeah, I'm gonna do it one more time because it's breaking my. Yeah. All right. So, okay. So I see the second part now. Bonus question: if photon travels from A to B at the speed of light, does it mean that the distance is longer because the path is wiggly rather than straightforward, or the speed of light is already plugged into that equation?
Right. So the answer is no. The path isn't longer, and the reason is this is a failure of the way we draw diagrams, right? Because we're showing this little arrow going like that, and what that really arrow is showing is distance in this direction and electric field in this direction. It's just going straight towards us.
This one broke my brain. Congratulations. Yeah. This actually broke my brain.
There are a lot of things like that where I think the diagrams we use just tend to introduce these concepts. So as a science educator, I apologize.
No, so would it be better to, I wonder, like, would it be better to visualize things like throwing a rock in a pond for like somebody who's absolutely new to this?
Yeah. I mean, one thing like I've learned from working in visualization is that you can't worry too much about misconceptions, because if you're so afraid of like giving someone a misconception, you're not going to give them a conception. And so any visualization, like anytime you get an idea across, it's going to lead to confusing other things, and it's more about prioritizing what people understand and what they don't. And then there's some people who think about things deeply and then ask this question, which is great.
That's an amazing question. It's amazing. Yeah, like let me find the name of who is this person?
Morris.
Yeah, Morris. I'm not going to pronounce their last name wrong. So I'll just not say. I'll just say Morris. That's a really good question. So it's really good. I love it when people think outside of the box like that, and then it comes back, and you're like, oh my God, there's a good point to that question. All right. Am I on? Okay, yeah. So this was the second question. I should have put this up earlier, but yeah. All right, so Patch and Noodle asks, Hi Mark, I am a high school physics teacher and am currently planning a unit around introductory astrophysics. I'm hoping for it to grow into a much more involved unit if the students show interest. Is there a topic you always wished you had covered more thoroughly while still at school? Also, here's a question from a student I was unable to properly answer during class. What if one black hole consumed another? The one I got wrong.
Yeah, yeah, that's a great question. So, I think for me, and I think if we think about like trying to inspire people in classes, one of the challenges with physics is you've got to build up all this knowledge to get to the crazy stuff we're talking about today, right? In fact, and most of the stuff we talked about today, even though I devoted my career to this, I never made it to most of it. I'm just talking about it, but I'm not an expert in almost any of the things that have been mentioned. So I guess I would say to Patch and Noodle, my advice would be, talk about the modern stuff and the out there stuff. That's stuff that gets people excited. You want to be able and do that early on. You want to motivate them to want to understand Newton's laws, and it's not because I want to do 17th century physics. It's because I want to be able to do 21st century physics, and I need to build up my knowledge. But if you don't get them excited about the things that are happening now, they won't want to build that up. So I would definitely talk about this kind of crazy stuff in your class. And it sounds like they do already, because they get questions like the black holes consuming one another, which is awesome. And that goes back to, this is what we're now able to observe. We're able to observe black holes consuming one another. What we measure is vibrations in space and time. We actually feel those vibrations coming, and for a little while, space will get bigger and smaller. Then measure that with the interferometer. So you send off 90 degrees lasers in each direction, and you bounce it back, and one direction will change more than the other. We're measuring incredibly tiny distances over, and these variations, which you're actually measuring as imprint, as that black hole spiraled in, and it's happening over like 1/10 of a second. And that's actually two giant black holes, each 30 times the mass of the sun, completely orbiting each other in 1/10 of a second, right? And it gets faster and faster, and makes this little, if you sonify it, like a little chirp as they come into each other.
Wow.
That black hole, so in many cases, a lot of that mass of the black hole disappears in the energy to create these waves. So you'll get like 3 solar masses that go away and just put into the making of a wave that travels throughout the universe.
That's crazy. Yeah, I sort of building onto what you said earlier. What I liked so much about Cosmic Wonder, or what I like so much about all of the Adler shows, is that you really do put just the right amount of time to explain how we know what we know, which does go into history a little bit, like goes into the history of astrology, astronomy and astrology, I guess. I'm thinking of the constellations and stuff like that in like the early stuff. And that actually was a really, really good way of understanding then, what you're talking about with the more complicated things, like actually going over that sort of almost fairy tale way of how we as a human civilization came to understand the stars above us. So yeah, I don't know. Props for that. But all right, this one's weird. It's a cab driver, and he wants to know, is he a body or does he have a body? And I don't know. I included this because maybe there's some meaning to it that I didn't get that you would.
Really? I was hoping you were going to answer this one.
yeah, it sort of moved into the I wondered if it had a. Yeah, we have not. I suppose we talked enough about simulation argument to sort of.
Yeah, and the nature of consciousness and what that is. And
yeah.
Of course, the reality is we don't know. The one thing all of us know about consciousness is that individually we can know if we have it, and that's really the only thing we can know.
Yeah, you have no idea of, and even then it's like we think we do, but
and we can't know if we have a body. We think we do, but we don't know that we do. But we do know that we have a consciousness.
Yeah. Imagine you were suddenly a character in a sci-fi novel, and you just made a fantastical discovery that will revolutionize the future of humanity. A completely new idea that is a synthesis of two previously known observations or principles. What is your discovery? I mean, doesn't it kind of feel like string theory was maybe this like this was like what string theory was attempting to be, maybe?
Well, it's trying to explain all of physics, but if we want to revolutionize the future of humanity, I mean, at some point, what is with a lot of these theories, in the fundamental nature of the universe, there could be huge. I think about energy, right? So if we want to revolutionize humanity, maybe we tap into a huge energy source. So maybe it is string theory and energy production or something that we're sticking together.
Yeah.
I don't know.
Yeah, and it's such like
That's a
it
cool
depends.
question. I wish I had a better answer.
It's like if you were to pry open that question more, it's like could you be like, well, I would bring quantum computing to its or is quantum computing one observation, and you could now merge that with, I don't know, Half-Life,
Maybe we're talking too much about consciousness, but right,
yeah.
it's like quantum computing and consciousness, and
Right.
we just upload all of ourselves.
Yeah, that'd be nice. When there are a lot of things we wouldn't have to worry about. You would have upload deniers, people who like went through the process of being uploaded, but thought it was a conspiracy, and yeah, I feel like that's a novel somewhere. All right, we still have 9 minutes, so I'm gonna look over. We made it through all the questions, and I'm gonna see if there are any in the comments that are worth hitting. Oh, there's so many, so I feel bad that I'm gonna be missing out a lot on. And again, for those who have just tuned in, this me being a pixel is sponsored by Comcast. Yeah, I wish. Unfortunately, the streaming platform I have, it's not as easy to see the chat. Anything left at the origin of the Bang? That's a pretty good question. Like, do we know where the origin was?
Yeah, and so the challenge there is that we tend to think of, well, because it was the maybe unfortunate naming, we always want to think of the Big Bang as an explosion. And if you think about it as like the creation, not just of matter and stuff, but the creation of space as well. Like you didn't have space and now you did have space. The Big Bang happened everywhere. So there's like no origin to the Big Bang. But in a way, you could also say the Big Bang happened everywhere. So, but yeah, people are often looking towards the center of the universe, and the fundamental tenet of the Big Bang theory is that there is no center to the universe.
Yeah. I guess we sort of think of it like a firecracker. It's like, what street was that firecracker located on? Anything else that's not trolling? A lot of people are like, science loves death, doesn't it? Yeah. Ooh, you know what? I have a question from a friend who is actually a fiber engineer.
Okay.
I'm thinking about how bad my internet connection is, and it's a friend who's a fiber engineer, and it's actually physics. So his he he seems. I guess I can't. I definitely can't explain this for him when he's asked me. I should probably take this comment off anyway because we're done here. So if you were to send fiber if you were to send an internet signal from Atlanta to Los Angeles, at some point in the fiber line, it would slow down. And then as it left the fiber line, it would speed back up to the speed of light again. And he doesn't understand how that's happening, or how that's possible.
So where's the slowing happening?
Somewhere inside the fiber line. I almost wish he was here so I
Yeah,
could actually have him break it down.
I mean, naively, I'd expect it's traveling at the speed of light. You get a little bit of, like, in fiber, things are bouncing around a little bit, so there's a little extra distance there, but it's not very significant.
Yeah, I think he just notices a difference. He's probably calculated it against the speed of light or something, and like noticed that there was a difference.
I just wonder if there are places where it's becoming an electronic signal, and that might be slowing things down. Or an amplifier or something like that might slow it down.
The bouncing around, actually, that actually makes a lot of sense, though. I think. Yeah, I wonder. I'll expand on it. What? Here's one from me. Simply because it's just I guess in your history of learning about all these things, and sort of me starting to learn about these things, but more in the sense of understanding reality or trying to explain different theories of it. How do you feel, like, where, on a scale from 1 to 10, with 1 being like absolute nonsense and 10 being something that is, a good theory, how do you view the ether? Like the sort of anti-relativity argument of the. Are you familiar with it that much?
Yeah, but do you mean like in a historical context, or
in a scientific one? Because there's a lot of people. I've run into communities of people that are pretty strong believers that the ether is actually the explanation for a lot of that the ether is an explanation for why astrophysics and particle physics have different.
really?
Can't connect. Yeah. And I actually have a book on it that I haven't read yet, but it's kind of.
No, I thought this was like I thought we figured this out, 130 years ago, whatever. Whatever it was. The Michelson-Morley experiment in Cleveland figured it out. So that would be a very low number. The ether, like, goes back to it actually was related to that question, like, a wave in what, right? So that was the initial idea of what light was traveling, and it was a wave in the ether.
It would. It's just one of those things that I'm fascinated with, just different theories. Obviously, like, it's not something that I cling on to, but I've been. It is hard to reach into that community and be like, okay, can you explain to me how everything works? Because I, just for entertainment's sake, could I understand, your perspective? But yeah, it is sort of coming out as a little bit more metaphysical than it, or a little more pseudoscience-y than having any sort of alternate explanation for how things work. Is there any sort of, if you were to, I guess there isn't really any sort of alternate explanation, because I've been looking for one forever, just for this project, not as something to believe in, but for something to, and science really does win at the end of the day, doesn't it? See if there's any. Oh, here's a good question, just random. How can I know if an acid or a base is weak or strong?
Wow, that's chemistry. Yeah,
Yeah,
I
that's
mean,
totally different.
well, I mean, you measure the pH, right?
Yeah.
So we have little strips of paper that can do that. But, yeah.
Yeah.
Um,
Yeah, that's pretty basic. All right, we got it. Well, it's 5 o'clock, and I think, and somehow, some way, I got through all of the previously asked questions in this time frame. I was kind of scared that I would have to leave some out, but we got every single one that was asked before Sunday afternoon, at least. And I want to thank Mark so much for coming. I want to thank my wife, Nick, for helping organize the questions and moderating the chat. Apparently, that has been happening as well. And of course, the reason we're doing this is for the bundle that you see right there on the screen. We're at over 44 albums of my music for over 30 hours of music, and you get to pay what you want, and you get to support the Adler Planetarium, which is the number one thing that I miss about living in Chicago, I think, is access to a facility like that, and just to have a facility like that around. But like I mentioned earlier, it's not just them, being closed this year is a big way that the Adler makes money and gets funding to do research. And a lot of that research is about the sustainability of your Earth, which we all need a whole lot of right now. So, yeah. Thanks so much for watching, everybody.
Yeah, thank you. And thank you, Ben. Thanks for supporting us.
Thanks for coming. Sorry about the potato quality. Right.
But my fiber connection looks great. I just checked it.
Okay. Maybe I will go back to Chicago.